Hello everyone and welcome back. Till the previous session we have learned about the different number systems. In this session we are going to learn about the addition in binary number system. So without any further ado, let's get to learning. Coming to the topics that we are going to cover in this session, at first we will learn about the foundation of addition, that is, how the basic addition is done. And then we will learn about the addition in binary. So let's begin with the foundation of addition. Now we are going to learn about the foundation of addition with our very familiar number system, that is decimal. Now let me perform a couple of additions to illustrate the foundation. Let's take two one-digit numbers, say 4 and 5. Now if we perform the addition, we all know what is going to be the answer. The result will be 9. Let's now perform another one. Say this time we are taking the one-digit numbers 7 and 3. And if we add them, the result is going to be 10. Correct? Now observe these two. From these two additions, we can state something. Now what is that? The addition of two one-digit numbers. Now if you notice, for both the cases, we added one-digit numbers, didn't we? So the addition of two one-digit numbers can result in either a one-digit number, which is true for this case. Adding 4 with 5, we got the one-digit number 9. Or a two-digit number, which happens to be true for the second case when we added 7 with 3 and got the result 10. This is a two-digit number, isn't it? So clearly, in decimal, addition of two one-digit numbers can result in either a one-digit number or a two-digit number. Now, since we are talking about additions, let me tell you the technical terms of each of the components. Now, the number to which we are adding another number, we call that oggend. So clearly, for this addition, the oggend is 4, and for this addition, the oggend is 7. On the other hand, the number which is being added to the oggend, we call that addend. So basically for this addition, the addend is 5, and for this addition, the addend is 3. Now what about the results? We call them sum. Now this is used in general terms. However, if we are to be specific, in case of this addition, we can call the 9 sum. On the other hand, for this addition, 0 will be called sum, and 1 we are going to call it carry. Now let me explain why we are naming it like this. Sum we can understand, but what is this carry? In order to understand this, let's perform another addition. This time we are going to take the oggend as 27, and the addend this time is going to be 3. Now we all know how to perform this addition, so let's do that. So 7 plus 3 will give us the result 10, and we will have 0 in this place. And what will happen to the 1? Will we place it in here this time? Not really. Instead, we will place it at the top of 2. Isn't it? So since we are adding 27 with 3, that's why after we got the sum as 0, we carried the next digit to this place. And that's the reason why we call it the carry. Now adding 1 with 2, we will get the result of this particular place, that is 3. So clearly, the result of the addition 27 plus 3 is 30. Now in this case, the entire answer is going to be our sum. Now what's the reason behind that? Try to understand it. With 27, that is a two-digit decimal number, we are adding 3. Well, not really 3, we are actually adding 03 with 27. Basically, we are adding two two-digit decimal numbers. And if you notice, as the result, we are also getting a two-digit decimal number. So, no carry this time. In this case, the entire result is the sum. Now the question is, why we are adding 1 with 2? That is, why the addition happened in this place. Now in order to illustrate that, let me perform the addition of only the digits in the units place. That is, we are now going to add 7 with 3. Now, since we are talking about the digits in the units place, the place value of these digits is 10 raised to the power 0. So when we add these two, we are going to get the result as 10. Notice, it is not a one-digit number, it is a two-digit number. And 0 has the place value of 10 raised to the power 0. What is the place value of 1 this time? It is 10 raised to the power 1. Now, along with 10, consider the number 27. Now observe, in case of both 10 and 27, the digits in the tens place are 1 and 2. Therefore, when we added 7 with 3, the outcome, which was the digit in the tens place, that is 1, is naturally supposed to be added with 2, right? And that exactly happened in this case. So clearly, due to the place value of these two, which in both the cases is 10 raised to the power 1, we performed the addition in here. And thus, we got the answer as 30. Now I hope why it is called carry and why exactly it is being added to the digit in this place is clear to you. Let me now ask you the next big question, that is, what will be the maximum value of carry? Now, in order to find that out, we need to consider all the symbols in decimal. Now, in decimal, we have got the symbols from 0 to 9. Now, in order to find out the maximum value of carry, we need to perform the addition of all the one-digit numbers possible. That is, for 0, we will add all the symbols starting from 0 to 9 with this. And the same will be repeated for 1, for 2, 3, 4, 5, 6, 7, 8, and 9. Basically, all these symbols will be added to all the symbols from 0 to 9. So basically, we will have to go through the additions of 100 patterns. Now, why exactly 100? Well, 10 symbols, and each one of them are being added with all the symbols 10 times. That is, 10 multiplied with 10, 100. Now, what exactly do I mean by 100 patterns? Well, the patterns are 0 plus 0, 0 plus 1, 0 plus 2, so on till 0 plus 9. All these 10 patterns, if we only consider 0 being added with all the other symbols. Now, after this, what is next in line? The next addition pattern is going to be 1 plus 0, isn't it? And so on, if we keep on adding the patterns, at last we will have 9 plus 9. That is, the addition of the largest symbols of decimal, 9 with 9. Now, what will be the results? Well, for 0 plus 0, it is going to be 0. Then we will have 1, 2. 0 plus 9 will result in 9. Then 1 plus 0 will result in 1. And finally, 9 plus 9 will result in 18. Notice, this is a two-digit number. And we were adding all the one digits. So when we added the largest one-digit numbers of decimal, we got the result as 18. So 8 is going to be the sum. And what will be the carry? 1. Therefore, the answer of the maximum value of carry is going to be 1. And this is true for any digit number of decimal. Let me prove that to you by performing an addition in real time. This time we will have the odd as 786, that is 786, and the add in this time is going to be 535. Notice, both of these numbers are 3-digit decimal numbers. And when we will perform the addition will be performed on every pair of these digits. And the reason behind that is, for these two digits, the place value is 10 raised to the power 0. For these two, the place value is 10 raised to the power 1, that is 10. And for these two, the most significant digits, the place value is 10 squared, that is 100. So clearly, although we are performing the addition of two 3-digit numbers, during the operation, the additions will be performed in each of these units. Let me illustrate what I am trying to explain. So if we add 6 with 5, the result is going to be 11, and we will have 1, that is the unit place 1, as the sum. Now what will happen to the digit of tens place of 11? That is the 1 in the tens place. That is going to be placed in here. That is, along with all the digits in the tens place. So 1 plus 8 will give us 9, and 9 plus 3 will result in 12. Now from 12, 2 of the units place will be kept in here, and the 1 of the tens place will be carried forward to the next digits place along with the digits of this place, that is the hundreds place. So 1 plus 7 will give us 8, and 8 plus 5 will result in 13, right? Since we didn't have any more place to carry the 1, therefore we placed it in here. Notice, every single time the maximum value of the carry was 1. And the reason for that is, when we performed the additions, we performed considering each of these units according to the place values. So that was all about the foundation of addition. Let's now focus on the addition in binary. Now, since we are performing addition in binary, do keep in mind all the knowledge that we have just gathered while we were learning about the foundation of addition. In case of binary, we have got the symbols 0 and 1. Now, if you recall, couple of moments ago, when we were trying to find out the maximum value of carry in case of decimal, we tried to perform the addition of all the possible one-digit numbers. And in order to do so, we had to go through 100 patterns. And the reason for that was, in decimal, we have got 10 symbols. However, in case of binary, we only have got 2 symbols. And therefore, finding out the patterns for binary will be way easier, right? Basically, for 0, we will have to perform addition with 0 and 1. And similarly for 1, we will have to perform 2 more additions with 0 and 1. So the patterns are going to be 0, 0, 0, 1, 1, 0 and 1, 1. Notice, these two are coming by adding 0 and 1 with the first symbol 0. And what about these two patterns? These are coming by performing addition of 0 and 1 with the second symbol, that is 1. Let's now try to perform the additions. Now with the oddend as 0 and the addend as 0 as well, we will have the sum as 0. When the oddend is 0 and the addend is 1, the sum is going to be 1. Then when the oddend is 1 and the addend is 0, the sum will again be 1. Now what will happen when both the oddend and the addends are 1s? Well, if we talk about decimal, adding 1 plus 1 would have resulted in 2. However, now we are dealing in binary. So what will be the result? We can also find that answer from this particular pattern as well. Let me explain. If you notice, this column is actually having the place value 2 raised to the power 0. And the reason for that is, in here, the symbols are changing one at a time. Now coming to the most significant column, notice the symbols are changing at the interval of 2. So the place value for this column we can imagine to be 2 raised to the power 1. Now notice, 0, 0 is nothing but 0. 0, 1 is clearly 1. Now after 0, 1, the next number in binary is bound to be 1, 0. And the reason for that is, we exhausted this place, so it was reset. And due to this, we introduced a new symbol in this place. Previously which was 0, now it is 1. So adding 1 with 1, we will get the next number, that is 1, 0. And since we are talking about the equivalent decimal values, what will be the equivalent decimal value of 1, 1 in binary? It is 3, isn't it? Anyway, coming back to our addition, 1 plus 1, that is adding 1 with 1, we will get the next number, that is 1, 0. So this time, 1, 0 will be the result. And as we have seen earlier, 0, that is the bit in this particular place, will be called sum. And the bit to the left of it is going to be called carry. Now let's name the oddends and the addends. Say we are naming the oddends as A, and the addends are being named as B. Now with the help of this information, we can actually form a table for addition in binary. Notice, when both A and B are zeros, what is the sum? It is 0. So in the column of sum, we are going to enlist that. Now when A is 0 and B is 1, that is this case, the sum is 1. So let's enlist that too. Coming to the next one, when A is 1 and B is 0, we got the sum as 1 as well. So we are going to enlist that as well. And finally, when both A and B's are 1s, that is this case, the sum is 0 and the carry is 1. Now for these three cases, we didn't really have any carries, did we? So clearly, these are empty. And we can symbolize empty using 0, can't we? So for these three cases, the column of the carry can be filled with zeros. Now this is called the truth table of addition in binary. Now why we are calling it truth table? Because at any point of time, if we perform the addition between these two symbols at any time, the results are going to be these only. And it will always be true for any number in binary. And trust me, using this truth table, we can perform any addition in binary. Let me prove that to you by performing an addition. This time, we are going to select 4-bit binary numbers, and the origin this time is going to be 1011, and the addend is going to be 1010. Let me perform the addition. Remember, we are going to take help from this particular truth table. Now notice the least significant bits, 1 and 0. So when A is 1 and B is 0, that is this particular case, the sum is going to be 1 and the carry will be 0. So we will have the sum as 1 and the carry as 0. Now 0 plus 1 will give us 1, and 1 plus 1, that is this particular case, it is supposed to give us the sum as 0 and the carry as 1. So let's have that. Now 1 plus 0 will give us the value 1. Once again, we will be adding 1 with 0, which will give us the sum as 1 and the carry as 0, isn't it? Now 0 plus 1 will give us 1, and 1 plus 1 will give us the sum as 0. Let's have that. And the carry is going to be 1. And once again, we don't really have any more most significant bits where we can place the carry to. So the carry will now become the most significant bit of the result. Now to be really honest, while doing the calculations, we don't really take care of the carries which are zeros. So let's omit those. Now we also need to find out whether our result is correct or not. And for that, I have told you how to do it. We need the place values. Now the origin and the addend both are 4-bit numbers. So the place values of the respective bit places are going to be 1, that is 2 raised to the power 0. For this place, it will be 2 or 2 raised to the power 1. For the next bit place, it is going to be 2 squared or 4. And for the most significant bits of both origin and addend, the place value is going to be 2 cubed or 8. Now coming to the result, it is a 5-bit number. So for the result specifically, the most significant bits place will have the place value 2 raised to the power 4 or 16. Now we have all the place values. Let's now check the equivalent decimal values so that we can judge whether our addition is correct or not. Let's consider the origin first. So 8 plus 2 will give us 10, plus 1 is going to give us 11 in decimal. What about the addend? 8 plus 2 will give us 10. So we are basically adding 11 with 10, which is supposed to give us the answer as 21. Have we got that? Let's check. 16 plus 4, 20. Adding that with 1, we will get 21. So yes, our addition was correct. And as you observed, we correctly performed the addition with the help of this truth table. I believe now it is an excellent time to give you some homework problems. I'm going to give you 2 homework problems. At first, a basic addition of 2 4-bit binary numbers. Coming to the next one, I have given you also the result this time. However, you need to figure out the missing bits. And I strongly believe with the help of the truth table, you can perform both of these easily. So in this session, we covered the topics, the foundation of addition, which we learned with the help of the decimal number system. Then we learned about the addition in binary. Alright people, that will be all for this session. In the next session, we are going to learn about the addition in hexadecimal number system. So I hope to see you in the next one. Thank you all for watching.